Hey guys, in today's video we are going to solve the problem 3507. Minimum pair removal to sort array I. You are given an integer array called nums. You are allowed to perform the following operation any number of times. Look at all adjacent pairs in the array. Find the pair whose sum is minimum. If more than one pair has the same minimum sum, you must choose the leftmost pair. Replace that pair with their sum, which reduces the array size by 1. Your goal is to find the minimum number of such operations required to make the array non-decreasing. Example 1 explanation. Let's take the input array. Nums equals array of 5231. Our goal is to make this array non-decreasing, means every element should be greater than or equal to the previous one, using the given operation. Step 1. Find the adjacent pair with the minimum sum. We look at all adjacent pairs. 5 plus 2 equals 7. 2 plus 3 is equal to 5. 3 plus 1 is equal to 4. The minimum sum is 4, and it comes from the pair 3 plus 1. So, according to the rule, we replace this pair with their sum. After replacement, the array becomes array of 524. This is our first operation. Step 2. Repeat the process. Now check the new adjacent pairs. 5 plus 2 equals 7. 2 plus 4 is equal to 6. The minimum sum is 6, from the pair 2, 4. We replace this pair with their sum. After replacement, the array becomes array of 5, 6. This is our second operation. Step 3. Check if the array is non-decreasing. Now the array is array of 5, 6. Since 6 greater than or equal to 5, the array is already non-decreasing. So we stop here. Final answer for example 1. We needed 2 operations to make the array non-decreasing. Output 2. Example 2 explanation. Now let's look at the second example. Nums equals array of 1, 2, 2. If we check the array, 2 greater than or equal to 1, 2 greater than or equal to 2, the array is already non-decreasing. That means no operations are required. Final answer for example 2. Output 0. This example clearly shows that if the array is already sorted, the answer is 0. Otherwise, we repeatedly merge the adjacent pair with the minimum sum until the array becomes non-decreasing. Here the Python solution. Let's walk through this solution step by step and understand how it works. At each step, we must pick the adjacent pair with the minimum sum, and if there are multiple such pairs, we always choose the leftmost one. First step, check if the array is already sorted. We start by defining a helper function called is_non_decreasing. This function simply scans the array from left to right and checks. If at any point the current element is smaller than the previous one, the array is not sorted. If we finish scanning without finding such a case, the array is already non-decreasing. If the array is already sorted, we immediately return 0 operations. Second step. Repeat until the array becomes non-decreasing. If the array is not sorted, we enter a loop that keeps running until it becomes non-decreasing. Each time we enter this loop, we increment operations _count, because we are about to perform one merge operation. We initialize 2 variables. Minimum _per sum to a very large value. Merge _position to keep track of where the minimum sum pair occurs. Third step. Find the adjacent pair with the minimum sum. Now we iterate through the array and calculate the sum of every adjacent pair. Nums of I1 plus nums of I. Whenever we find a smaller sum than what we've seen before, we update minimum _pair _sum. We store the index where this pair ends. By the end of this loop, we know exactly which adjacent pair must be merged, following the problem's rules. Fourth step. Merge the selected pair. Once we know the correct pair, we replace the left element of the pair with the computed sum. Then we shift all elements to the right of the pair 1 position left, effectively removing one element from the array. We reduce the array length by 1. This simulates the operation described in the problem. Fifth step. Repeat until sorted. After merging, we again check if the array is non-decreasing. If not, we repeat the same process. If yes, we stop and return the total number of operations performed. Alright, Now let's run the code with our example input. Great, this matches the expected answer perfectly. Since the output matches the expected result, let's go ahead and submit the solution. Submission successful. You can see that the solution is accepted, and it correctly handles both sorted and unsorted cases. This confirms that our approach works as intended. So that's how we solve this problem. This is a great problem to understand greedy simulation and array manipulation. If you found this explanation helpful, make sure to like the video, subscribe to the channel, and check the problem solution link in the description. I'll see you in the next LeetCode Daily Challenge.